name is Claes Harlin. I'm a sales engineer here at Tacton. And today I'm going to talk to you about three things. First, I'm going to talk about how do you set up a product configuration? How do you create a configuration model? And then we'll have a look on how do we release it to the end users in the system. And we'll walk through the process of configuring, pricing, and quoting this and offering it to a customer. All right, let's dig in. I have a couple of slides I will show you that are outlining these topics. So we'll start with the first, a little overview on what is the Tacton CPQ. So, to start off, CPQ is an abbreviation, and it's an abbreviation of configure, price, and quote. Within the Tacton portfolio, we have a couple of different views on this. The first is that to your Tacton CPQ, the core of Tacton CPQ, you can add visualization. You can add 3D real-time visualization. We can also integrate the Tacton CPQ into your engineering processes, and we do that with tools that we call CAD automation, and that's the generation of CAD documents already at the point of sale. It's also possible to publish the Tacton CPQ to different channels. So we offer omni-channel experience when addressing your customers. It could be, for example, through a lead generator available on your web page. You allow your customers to go in and configure the product that you're selling. We also offer analytics to do some business insights around the Tacton CPQ. What has been offered? What is the win rate? What options are selected when you win? And we also have a suite of tools that would suit your engineering processes and work within engineering that we call design automation. All right, the CPQ itself, it consists of two big main parts. One is the front-end application, where sales representatives, the direct sales channel, would work. In that, it has three engines. One engine is responsible for the configuration of products. One is responsible for pricing, and the third one is responsible for generating different kinds of documents. Obviously, to make this happen, we need to prepare a backend. So the other big application is the backend application, or what we call the Tacton CPQ administration. Today we are going to look on product modeling, and that's how you define your configuration models. And then we're going to look on price modeling, and we'll actually exclude from today the document template generation. All this will happen in the Tacton CPQ administration. There is a data model within the Tacton CPQ. We have a couple of objects that are always present. So for instance, we have an account. If we're going to configure something for a customer, it always has an account. It's going to be offered for someone. It has an opportunity. To that opportunity would tie a solution. And to the solution, we will add the configured products and other products. The nice thing about the setup for Tacton CPQ is that it has been prepared in a way so the data model is actually configurable in itself. If you, for your company, need an additional object, let's say that you need an object that is later used just to carry some information over for integration to the ERP, it's easy to add additional objects to this. So we can add custom objects and custom attributes. Tacton CPQ is also offered as software as a service. This means that within your company, you can remove a lot of the costs of keeping up the infrastructure on the IT side. The Tacton CPQ has also been proven through many years and many different manufacturers and have been adapted, so it's very easy to create integrations to all the business critical systems around us in the landscape. So it's easy to leverage your investments in CRM, ERP, if you have a PIM system, if you have PLM, or if you want to distribute this through an e-commerce. we remove a lot of manual work and emails flying back and forth through integrations instead and a workflow in Tacton CPQ. All the APIs are open, and it makes it very easy for us to make sure that we have a continuous data flow in this. And it's also very scalable and efficient. Let's start talking a few words around configuration. So here at Tacton, obviously, we like configuration. We've been working with configuration even since the company started. And we have seen that through all time, there has been an evolution to the configurators. And we've seen three generations in the different kinds of configurators. And the first one is the sequential ones. And we'll look on how would you select a tire fitting to a rim that would build up a wheel with these three different approaches. First of all, if we do it rule-based with if-thens, well, then we have a very sequential configurator. We say that if you select a certain size of the wheel, if you have that size of rim, then the tire size must be this, this, or that. And then when a wheel has been constructed, if you want to select a brake for that, we have certain rules for that. These configurators, they work well, at least in one direction. The issue comes when you come to the end of your configuration, and then you realize that I have a 20-inch wheel, but I don't want to have a drum brake. With a sequential configurator, that would mean that you need to start all over again. Go from the beginning. There's also another issue with this, and that is if you want to add a wheel size. This has to be done in many, many different places. Sort of the configuration rules and the product data, they live together in one place. And that has some negative implications. So configurators actually evolved a bit. And the second generation of configurators came up with something called a relation-based configuration. You will span up a table or a matrix saying these items are friends and these are foes. So in this example, we have 3 tires, we have 3 rims. We say that tire 1 fits the rim A. Tire 2 fits the rim B. Tire 3, rim C. And we define all those relations. And here we see a table representing that with a cross. So, all right, you gain a couple of things with doing it this way. One thing you gain is we're not sequential anymore. This means that we could select the rim first and then get suggested a tire. Or we could start with a tire and then get the rim. However, when it comes to the maintenance of these kinds of systems, we see here already for these 6 components, we have a lot of relations and a lot of crosses. So these tend to explode in size. If we scale this up to something looking similar to what an actual product complexity would be, these tables tend to be astronomically big. So companies working with configurators using this background technology, they tend to have a whole department of people just validating and updating rules. There must be a better way. There must have been evolvement since these 2 steps. Then we have the 3rd generation of configurators, and that's actually where Tacton is. Constraint-based configurators. We are setting up relationships between the components described with why 2 parts are compatible. So we're assigning them features, and then we're saying why those features and what the relationship is between those features. So for instance, why would the tire fit a specific rim? Well, if the tire inner diameter matches the rim outer diameter, then the 2 will go together. So this is something that we think is quite close to how the product managers and the engineers working with these products think. And we actually state our configuration rules exactly like this. We might need additional rules in this. And for instance, here we have set up a way of saying that all the components in this configuration problem that has a feature called width, those widths should match, should have the same value. And that we say with this magical constraint saying all select width equal. So we have two criteria to say that these fit together. The width should be equal and the inner diameter of the tire should match the outer diameter of the rim. Here at Tacton, we not only have a constraint-based configurator, we actually have a constraint solver. And this means that all of these rules will be evaluated at the same time. So it's totally unsequential. You can start with selecting the width. You can start with selecting the tire, you will get suggested a rim. There is a big difference between the previous technologies and this. In the previous technologies, you need to define for the configurator what is the configuration problem, what are the components, and exactly how do you solve every scenario. With a constraint-based, you tell the configurator what is the configuration problem, what are the criteria for the components to go together, and then you ask the configurator engine to provide us with the solution. So in a sequential based, you need to program the problem and how to solve it for every case. With the constraint-based solver, you set up the constraints and the configurator engine provides you with the solution. It also, since it's unsequential and we can add rules while we go, means that we can actually have a layered approach. We can start out building a configurator that has only the technical constraints. And the width and the diameters we've been talking about, those are typical technical constraints. On top of that, we could add marketing constraints. That would be saying things like, for America, we only want to offer certain sizes or certain packages. Then we can have local constraints. For instance, I'm based here in Stockholm, Sweden. We get very cold winters. This means that if I would like to buy a tire and a rim that is suitable for winter conditions, that would mean that I actually by law here in Sweden need to have winter tires. So that could be a local constraint saying that if the market is this and the use period will be this, I need to have a winter tire. And then on the topmost level, we have a concept we call need-based configuration or guided selling. And that means that I can ask the end user, instead of asking the end user what kind of tire diameter, if you don't know, maybe we would ask things like, where are you going to drive? In what temperatures? What kind of road conditions? And then we let the configurator taking care of offering the optimal combination of components for that specification. All right, let's talk a little bit about how the constraint solver works behind the curtain or behind under the hood. In this picture, we have tried to represent the configuration problem with this box. It's a maze. And right now, we only have an entry and an exit. The first thing that Tacton configurator will do before we put in any constraints, if it wants to find a solution, it will be very lazy. It will go into the list of available components, and then it will just say, I'll take the smallest one in each of the tables, the first one I find, with the smallest diameter. So if you would take the wheels and tires example, by default it will be lazy. If you don't select anything, it will take the smallest rim and the smallest tire and see if they fit together. And if they fit together, it will be happy and feel that now I found a solution. But then we start putting in the constraints in it. And in this picture, it's represented by all the walls in this maze. Still, the configurator trying to find a way through this maze First, it will actually figure out a thing that we call a propagation, a domain validation. So for instance, it might be so that we have put in some rules saying that you can never go to the areas here in the ends. I mean, if we have constraints allowing us to have a 19-inch rim, but we don't have a 19-inch tire, then the configurator will actually figure out that, all right, the 19-inch rim will never be selected. We can exclude that from the problem. Then it will actually go through the maze by going in, selecting the smallest in every one of them. There is also a possibility to ask the configurator engine to find the best solution through the maze. So we can tell it certain things. Either we tell it to select the ones that has the lowest purchase price or lowest weight. And let's say that in this maze we put in a little, this triangle here is representing that now the end customer has done a selection. That selection could be a thing like I was talking about. I will use it in the winter. Then the configurator will actually mark a couple of the areas in the maze gray. And these gray areas means that these are the summer tires. They're possible to select, but they're not suitable for this specification. And if I do additional selections, I say that I want to drive in the winter, I want to have aluminium tires, aluminium rims. That would increase the gray areas. Now I can't select the steel rims anymore. And for instance, as an example, selecting a steel rim then would be an incompatible option. The end user can actually still select a steel rim. And if the end user selects a steel rim, it will be prompted, get a prompt from the configurator saying the choice of a steel rim is incompatible with your previous choice of only having aluminium for rim material. And then we let the end user decide what is most important for me. Is it the steel rim or the material choice in the beginning? So we have automatic advice on how to solve the conflicts in this. Before I leave this slide, it also means that the configurator knows all possible solutions to all of these configuration problems. However, what we view and present to different users. For instance, you might want to show one view for your technical sales support. But then if you want to make this configurator available on your homepage, that would mean that you would show a different view there. All right, let's look on how would we actually build up a configuration model for this. So the logic we have to the left is that we built a tree structure representing this product configurator. So we have a wheel, a tire, and a rim. And then we start assigning some features to that. We have an outer diameter on the rim, we have an inner diameter on the tire, they have a width, and then we put configuration rules on top. Then to the right here we have some product data. These two are actually separated. This means that we could change the product data without changing the logic at all. With these rules, if I select tire A, I will get offered rim number C. But since I've separated the product logic from the product data, means that I can easily add product data. I could let the ERP system just push in all the rims we have available this week. And the configurator still works with the same configuration rules. Because the rules and the logic for the problem and the data, the rules and the logic tend to change very rarely. That's just when you change the product architecture and do a re-engineering. But the product data, what's available this week, it can be up to what components we source this month. That tends to change very often, in comparison at least. I talked about these multiple constraint sets that we can have. I mean, first of all, we have these technical constraints. all the little dots in this picture represent one solution to a rim and a tire. So if I first add the technical constraints saying what needs to fit together, the configurator can gray out all the area outside of this, figure out that this will never be offered with these technical constraints. I was talking about a 19-inch rim, but I don't have any 19-inch tires. Then we'll start adding marketing constraints. Things like if I have a 4x4, the tire type should be all-terrain. If I have a sports car, we would say that we would default the rim material to be aluminum. I can have local constraints saying if I offer a winter tire here in Sweden, but let's say that I select the market to be Spain, there's no need to offer any winter tires. And then on top, we can have things like the guided selling layer. We base it on customer needs instead. What are the road conditions? How often? What type of vehicle? And then you would need different offerings for different scenarios. And in the end, what we have here is what we call the solution space, still available. Within the solution space, we can use this optimization, saying select the one with the lowest weight, the lowest price, the shortest delivery time, or the best performance. So we can actually tweak how the configurator is finding its solutions and which one it picks to be best, or what it seems fit as the most appropriate. What is the optimum? In the toolbox here, we have a couple of things in our toolbox. We have constraints, like arithmetic ones, like adding a value, subtracting a value, multiplying, dividing. We have relationships between two attributes. Things can be equal, things can be bigger than or smaller than. We can have conditional. However, a recommendation already now is, since we have a constraint solver, we don't need to have conditional constraints. You don't have to use the if, then, else. We can of course have the logical operators like and, or, XOR, not. We also have a way of saying this. I talked about the rim width being equal. That's a type of aggregation. Set a big set of attributes to be the same. I can summarize things if I want to calculate the total weight of what has been selected. I can minimize and maximize on things. And we also have a tool that's called combination tables. So that's, you would set up a table with scenarios. Like for instance, if the market is Spain, prioritize selecting tires that are suitable for a summer climate. If the country is Sweden, prioritize to select winter tires. So if we take a look on something completely different, but kind of the same. Here is an example that we have one electric engine, and then we have a gearbox. In Tacton product modeling, done in the administration, we build up something we call assemblies. First one would be having a drive assembly on top. Then we have an engine assembly, or an engine position in this. And then we have a gearbox position. We assign that the engines should find its module variants from a table, an engine module, and within that you should look for module variants. The module variants is a way of defining what's currently in the portfolio. So engine number 1, for the attribute of protection class, it has IP65. The output is 20, and the voltage is 110 volt. So here is the data of the specific different engines, or module variants, specific lines that we have. Then I would start writing logic for this. So engine output should be equal to gearbox input. So let's say that the output and inputs are things like Newton meters, so some kind of torque. They need to fit together. I want to aggregate the protection clause, so make sure that all things that are selected have the same protection clause. All right, that was a big and quite thorough preface, but let's have a look on product modeling in this. So the highest level we have in product modeling is that we want to build a product model, configuration model for a certain thing. Then we will build one of these structures that we talked about, an assembly structure. The assembly will consist of multiple positions. A position for this gearbox, a position for this motor. Then we'll tell the position that you will get your data. You will fill in your data with the modules. And for the engine, you will select the engine module. The module has features on it, like this output protection clause. The feature, of course, itself has a domain. What are the allowed values for this feature? And then we have the specific variants of this module, and those are called module variants. The module variants doesn't only have a feature, they have a value on each feature. So protection clause for module variant 1 might be IP65. The assembly can have additional attributes in itself. They also have domains. And on the assembly level is where we define the relationship between the positions, and that is what we call constraints. And then for the top level of the product model, we decide on how should we present this for different users, and that's what we call a design view. And on the product model level, if we want to set defaults, like try to always set the brim material to be aluminium, that would be on top as default values. There is a level below the module variant that is not too much used in sake of the configuration problem, but it might have other implications, like it might have a cost that is used in price calculation. It might have charges added to that. It might have an engineering part corresponding to it. So all right, the three important topics: product models, how you view it to the end users. Then we have the assemblies. What is my product architecture? What are the nodes? And then the modules. What modules do I have? What modules go together with certain assemblies? Let us jump over to the Tacton CPQ administration. And for making this a bit more real, I have logged into the administration of a made-up company we have called Tacton, a truck manufacturer. So isn't it quite suitable to have some wheels and tires that we offer for that? What we see when we log into the administration is that we have a long list of tickets here. And why is that? Well, every change we do to an environment is done through a ticket. When a ticket is released and done, that actually brings us to creating a version master. And currently we can see that the current master version is 246, and that the connected environment, the front end, is running on 246 as well. And then if I do a change, when I'm done with that change, that would create version 247, so the new version. And then it can be chosen when to promote version 247 to go all the way to the front end and the end users. The nice thing about these tickets is that the ticket, it contains all the information of the CPQ. That also enables that in each ticket I have a test environment containing all the information and all the changes in that ticket. So I can test every change in a complete CPQ environment, but without disturbing what's out in the front end. Now we are going to look on this example with creating a configuration model for wheels and tires. Here to the left we have a couple of different objects. So everything that has to do with the sales process are gathered under this heading. So here we have things like the structure, what's the layout, what's the permissions in the front end. I have a section for master data like cost lists, price lists, setting up the price model, calculating the prices in the end. But the heading we are interested in now is the one for creating configuration models, the heading called product modeling. And let's start from the bottom. We said that we needed modules in this. So if I go to the modules, I see a long list of all the modules I have in the company called Tacton. And I prepared a bit just for time's sake here. So I prepared a rim module here. In that rim module, I had defined that the rims have two features. They all have a width, they all have an outer diameter. I have defined three variants, rim A, B, and C. Each of them have their own values for width and outer diameter. On the other end in the modules, I also have a tire module. In the tire modules, I've created three module variants as well, A, B, and C. They have different values on the inner diameters and different widths. Then the next level of this, once I have modules, I can start creating an assembly. And what I've created is I've created a wheel assembly. To that wheel assembly, I've added a couple of things. I've added two positions. I have a rim position, and if we open that one, we see a couple of options in this one. A rim position that has a description called a rim. It's the type module. So a position could point to a module coming from module variants, or it could actually point out another assembly. So this product structure and the way we build up the structure of the product can be created in a way that represents the product architecture. So if we have sub-assemblies, like we talked earlier around an example with an engine and a gearbox, maybe the gearbox itself is not a module variant, but it's in its own assembly. I also say that I have a static number of rims, and that's 1. It can be configurable. It can be decided by a sizing calculation or other ways of determining how many rims I should have. The same thing I've done for a tire position. So 1 rim and 1 tire. And the tire position is in turn pointing out that it gets its value from the tire module. All right. Now it's time for us to actually define the relationships between the rims and the tires. We have the two main ways of doing this are either through something we call an aggregation of attributes. To accommodate this, I've created a top-level attribute called wheel width on the top here. For wheel width, I can say that what do I want to aggregate that? We have different aggregations. Either I could use something called a sum. That's typically used if you want to count something. How many tires have I added? How many bolts do I have in my assembly? Or if I want to summarize a thing like I have a weight feature on a lot of the rims, I want to calculate the total weight. Then I would use sum. In this case, we want to use an aggregation we call equal. That's a part in our toolbox. I'll save that one. And then I need to go into the aggregation and tell the configurator what attributes where in my product structure should be equal to each other. So for instance, I can in this tick list say the rim position width and the tire position width should be equal to this top width. And then I say in the actions, include it in the aggregation. I have these tick boxes. Or actually there's another way of doing it. I have this plus and minus. So I want to add that one in the aggregation. This actually means that I could take a lot of different attributes and add them to the same aggregation. They doesn't necessarily need to have the same name. As long as they are defined with the same domain, it's fine to aggregate them. All right. Then of course I could have done exactly the same thing with a constraint. Let's create a constraint that would do a similar thing. So I go into the constraints menu, I will add a constraint and say that the rim position outer diameter should be equal to the tire position in a diameter. With this, I've added the two configuration rules I need for a wheel and a tire, and we should be ready to go. And actually, every assembly has a little user interface that can be run. So quickly, let's just go in and run this. However, we must remember that this user interface is mostly for debugging. It's just for testing the logic that the constraints really work. So I get a user interface that's pre-generated and it just shows everything. So for instance, if I go to I can select a width here on the top level. Let's say that I want a 220 of something. Then I can see actually, both here in the assembly tree, what happens. Well, then it has changed the selection of the rims and the tires to select a rim and a tire with 220 millimeters of width. Another way of doing this would be to go into the bill of material configuration and see if I select rim A, what tire do I get? Yeah, first of all, I selected a width in the beginning. Now it says that if I select rim A, I must change the width. I get this conflict resolution. I need to change it to 250. Let's accept that for now. So rim A goes together with tire C, and tire C only. And then I can go in and check the features of the rim. So for instance, the width is 250, the outer diameter is 670, and if I check the tire, the inner diameter is 670 and the width is 250. So it seems like my logic checks out. Going back to this boom configurator, let's try one of the other ones. All right. With this, the only thing I have left to do now is to design how I want to present this to the sales users that's going to use this. So to do that, I've created a product model, a level above assembly, called wheel. In that, I've gone into a view designer and created a custom view. Again, there is a possibility to run this user interface to fault find and test that it works. But when we reach this point, come this far, what we can do is go up one level above that and create a product. So I create a product called wheel. I give it a description, internal names, product IDs, things like that. I can upload a thing like an image to that one. And then I point out that the model, the wheel model, is supposed to be used for this new product. And when I reach this point, I'm all ready to start a test environment. Test is all the way in the CPQ. So I will log in as a sales representative. So now I'm pretending within my ticket, I'm not changing anything in the front end because this has not been released, the ticket has not been finalized. But I can go in and see exactly how the environment would look for a sales representative. And for instance, I could create a new opportunity. I'll call it test opportunity on the test account. For that opportunity, I will create a solution. And this is exactly how a sales representative would work with this. I put it on a country. And here you see the solution object. Like everything else in the Tacton CPQ, we can configure how this should look, what kind of colors we have, who should see what. It's very flexible in that. I have a workflow that's been set up for this truck company. They have these phases when they create a project. And here I can start adding products. And now I have two products. So I have a wheel product and I have a truck product. What I will do is I'll go in and select the wheel product so we can test this. And now with the user interface I have decided and created in the view designer, I can now check if I select rim A, to that I am suggested to have tire C. I have a wheel size that's 670. I have a wheel width that's 250. I can interact a couple of different ways with this. Let's say that I would like to select directly what kind of width I would like to have. Let's try to have 270. Is that possible? 170. Oh, that was actually out of bounds. But let's try to do 271. What happens then? Well, it's actually way out of all the... If I change this to tire B, what would I get then? Well, if I change the tire now, it wants to change to a different rim. So you see, it's not sequential in any way. I can start figuring out what wheel width I would like, or I could start with selecting a rim and then get the tire selected. Or now I'm trying to change the tire, and then it needs to change the wheel to get it to fit. And now I have a wheel width of 220. If I would like to go back to a wheel width of 250, I can still do that. And then it says that it needs to change both the rim and the tire. So even if I have multiple consequences of previous choices, it will show me a way forward. All right, let's finish and save that one. I have views in the configuration view for visualization. I have views for pricing. We haven't added the price lists and the data needed for that. I do have a bill of material. In this wheel example, it's just the rim and a tire, so it's quite small. But I can view the result of this. I will see a little summary. I can save that. So on my solution now, I have one line item, and that's the newly configured wheel. If I would like to continue on working with this, I could add other products. So for instance, let's just very quickly look at the truck. So if I go into the truck configurator, we see here that all of a sudden we have all of these are filled in. So first of all, I have a 3D visualization of a truck. And the 3D visualization of the truck I have configured so far. We actually have in the first group the customer needs. So this one actually utilizes the need-based configuration. So if I just answer what kind of traffic will I use it in, what kind of topography, is it very hilly? Will I drive on dirt roads? Based on these selections, a customer need selection, I would get suggestions on what I need in my bill of material. So for instance, when I change to dirt road, my last change, I now get a 4-point cab suspension. I get some shock absorber checkup on a regular basic. And if I go to poor asphalt instead, well, probably I will get other suggestions that I need a different rear axle. With this, I will finish that configuration and save. So even not being a truck expert, just answering 3 questions on what I need, I have a complete truck specification. In this case, we have a complete bill of material created for it. I also have price connected to those items and a total price calculated. So this means that I'm now ready to go to the next step, to the proposal stage, create a proposal for the customer. And for now, I will just generate a firm proposal straight away. And that means that we would, from the configured product with those prices, create a dynamic document that is corresponding to the configured products, the account it has been prepared for, who it has been prepared by. So a dynamic document taking into consideration all these things. And now I'm ready to offer this to the end customer. If we validate this and are happy with it, what we can do then is close our ticket test environment, go to our ticket, and say that this ticket is now done. And if I'm the correct level of administrator, I could actually say that in the version and release management, I take my newly created ticket and commit that as version 247. And once that is done, I'm ready to distribute it to the front-end users. All right, let's not do that today. That's a job for another day. If we just go back to our little presentation to wrap this up. We have now seen actually exactly how this creation is done. We've created these modules and assemblies. I talked briefly that the structure actually makes it possible for us to reuse assemblies in different contexts. We looked on the scenario of a made-up truck company. We pretended to be a sales representative doing configuration. We just accepted the out-of-the-box, accepted the pricing set to it by the CPQ, and we created a quick quotation. But what are the values of doing the configuration this way? Well, you want to sell your product based on what your end customer needs instead of technical specification. You don't want to, if you're not a truck expert, you don't want to buy a truck based on what kind of engine it has or the model number of the gearbox. As a truck buyer, you're interested in how am I going to use it? I want one suitable for my needs. You want to increase your accuracy in sales. You want a single source of truth for the product and pricing data. The conflict resolution of our configurator makes sure that you never end up in a dead end. You can never go into a case that means that you would need to start over with the customer. This is making it very hard actually to make mistakes. You saw me. I'm definitely not a truck expert, but just answering a couple of questions, I could offer a complete truck to a customer with a complete bill of material. It also allows me to offer the optimal solution based on the customer needs. This would actually mean that you have a much faster ramp up and onboarding of new sales representatives in your company. You have a way of controlling new product introduction to this. And we must remember, all this that we do is for you to be more responsive to customer inquiries so that you quickly can provide them with a quote and a price that is accurate and producible. And with this, I would like to thank you very much for attending this. And you have now seen how we can make trusted configuration and make sales simple if you're in complex manufacturing.